Alright, you're probably getting tired of these, and so am I. To be completely honest with you, I'll make this one and maybe one more tops, or maybe I'll call it good after this one. This is a new section, 47. This is in the grams. No, it's not. It's in the moles to liter section, or vice versa. I hope you don't care I switched to blue. It just felt like it needed to be changed. All right. It says acid rain is produced when sulfur trioxide reacts with water in a composition reaction. This is a controversial reaction. Kids often don't know what to do because it looks as though it violates my rules, and it kind of does. But it tells you its composition, so you don't need to think that it's a double replacement even though it looks like one. All right, so it tells you if 35 liters of sulfur trioxide is present in the air, how many moles of sulfuric acid are produced. So it tells you the product on the right side is sulfuric acid. From your naming schematic, you could look and see that that is H2SO4, which is very nice because there's two H's, 4 O's, and 1 S. So this is all just ones when we balance it out. So that's our first step, if you remember, was to write and balance the equation. Our second step is to find what we want in our answer. All right? These lines are awesome. What we want in our answer, it says how many moles of sulfuric acid are produced. So I'm going to write moles, H2SO4. The third step was to start with what I was given, 35 liters of SO3. Now, every single one of these picket fence problems starts the same way. You need to balance a reaction, find what's wanted, find what you start with, and then just solve. To solve, we use the map. Now, this is a new one. We are going, if we look one more time, from liters. All right, we start with liters, and we're going to end in moles. So go to the map, and let's follow this out. Make it a little smaller here. Whoops. So that we can do all. Well, let's do this to last night too. I don't care. All right, so liters is right here, and we want to end in moles. So we're going to go down, and then we're going to go over. We could go over and down, but if we do that, the units get a little tricky. So I recommend you always go down and then over. All right, so here is a new relationship to us. It's how we convert moles of a gas to volume of a gas, or vice versa. It tells us that for every 1 mole of a gas, 22.4 liters of it, it occupies, let me start over. If we have a mole of gas, it's occupying 22.4 liters of volume. That's a constant. It's always the same, so we don't necessarily need to worry about it. We just need to memorize it and or look here. So let's go back to our problem. We're going to use this proportion and then go across using the ratio of coefficients. So I know whatever unit is here goes there. So liters, SO3. That ratio we just looked at said 22.4 liters of SO3 will occupy, or 1 mole will occupy that. All right. Next, we have ratio of coefficients. Whatever is here goes on bottom. So I have mole SO3. Whatever I want is on top. Moles H2SO4. Both of them are 1s. So 1 and 1. So I'm ready to do the math. I'm going to take 35 and I'm going to divide it by 22.4. And that should be around 1.56. If I typed it into my calculator correctly, we could do the reasonability check. We should say, okay, we have 35 liters. We know that it's going to, for every 1 mole, it's 22.4. So it has to be roughly 35/24, which is exactly what I typed in. That's 1.5, roughly, I don't know,